Assalamualaikum to Encik Khairul Nizam and friend. My name is Nur Binti Muhammad Syaimin. Matric number is 08DKM20F1063 and my group members Nur Ayu Dalila binti Khairul Nasir 08DKM20F1062, Wong Yiwen 08DKM20F1060, Wong Susan 0FDKM20F1072, and last Ahmad Shukri bin Amran 08DKM20F1057. So today our group will present about steam power. 1.1 Use of steam power plant, steam turbine and safety inspection of boiler, tubes and drum. Definition: steam power plant is defined as a power station where we generate electricity using a steam-driven electric generator. The use of steam in power plant. Steam in industry use: the first one for steam for heating, second steam for propulsion or drive, third steam as motive fluid, fourth steam for atomization, 5 steam for cleaning, 6 steam for moisturization, and 7 steam for humidification. Application of steam is heating or sterilization, second propulsion or drive, third motive, 4 atomization, 5 cleaning, 6 moisturization, and 7 humidification. Steam power plant layout. The layout of the steam power plant consists of the following parts. Those are cold and ash handling unit, boiler, superheater, steam turbine, generator, condenser, economizer, feed pump, cooling tower, and chimney. Component of steam power plant. The first one is cold and ash handling unit. Before feeding the coal to the furnace, it is to be converted into the pulverized form, and after the combustion, the ash is collected in the ash handling unit. Boiler. The equipment used for producing steam is called boiler or steam generator. Superheater. The steam is taken out from the boiler and is superheated so that the steam should be free from the water molecule. Steam turbine. The steam which is free from water molecules are used to strike the blade of the turbine so that large amount of power can be generated. Generator. A generator that converts one form of energy to another is attached to the rotor of the turbine, and as the turbine rotates, it also rotates with the speed of turbine. Condenser. The steam after striking on the blade of the turbine intake into the condenser where it gets condensed with the help of cool water from the cooling tower. Economizer. The steam after striking on the blade of the turbine intake into the condenser where it gets condensed with the help of cool water from the cooling water. Cooling tower. Feed pump. This feed water is to be sent to the boiler using a feed pump only. Cooling water used for the water that is used to condense the steam in the condenser was supplied from the cooling tower. Fuel and handling system. The fuel processing and handling is used for preparation of coal or lightning or agro fuels to be used as a fuel in FPC, boiler, hot air generator, and other multi-fuel fire system in various industries. The fuel processing is used to produce fuel of right size suitable as per the specification of the FPC boiler or heaters. There are a few types of fuel and handling process such as baggage handling and filling system, coal handling and filling system, and ash handling system. The steam turbine. Pure impulse turbine. The impulse turbine consists of a row of nozzle followed by a row of blades. The gas is expanded in the nozzle, converting the high thermal energy into kinetic energy. The high velocity gas impinges on the blade where a large portion of the kinetic energy of the moving gas stream is converted into turbine shaft work. The static pressure decreases in the nozzle with a corresponding increase the absolute velocity. The absolute velocity is then reduced in the rotor, but the static pressure and the relative velocity remain constant. As you can see the picture, steam turbine machine the flow of steam through impulse turbine. Reaction turbine. In a reaction turbine, the water enters the valve under pressure and flow over the vane as the water flowing over the vane is under pressure. Therefore, the valve of the turbine runs full and may be submerged below the terrace or may discharge into the atmosphere. While flowing over the vanes, the pressure head of water is converted into velocity head and is finally reduced to the atmospheric pressure before leaving the vane. Application of steam turbine. The first one is chemical industry, providing heat and electricity to drive different processes in the chemical and pharmaceutical industries. Steam turbines are integrated in the process of producing power. Second is waste plant. Steam turbines help generate the power needed to harness energy from waste. Third is oil and gas, used as a pump drive or a compressor. Steam turbines support dozens of operations in the oil and gas industry. And lastly is sugar mills, offering a high level of efficiency and sustainable operations. Steam turbines are used to produce green carbon dioxide energy from biogas. Safety inspection of boiler, tube and drum. A trace of oil leaks can start as a result of minor crack in HFO heating coil or indifferent heater in the engine room or in other place where steam is used for heating. In a complex engine room today, there are several possibilities for oil leak to occur. Thin layers of oil are not always visible. B. Erosion. Erosion is caused by the velocity of steam across a surface. It used to be a big problem in other boiler design where you could see the erosion around the steam outlet nozzle in the steam drum and also at the tube entry point in the tube plate. C. Breaking on the boiler drum. Root causes of this accident can be possibly due to the combination one or more of these factors: low water, misalignment of furnace nozzle, the formation of scale on the furnace wall on the water side, and operation which does not comply to Dutch safety requirements. D. Blister on the boiler drum. A blister may be caused by a defect in the metal, such as a lamination where the side exposed to the fire overhead, but the other side retains its strength due to cooling effect of water or other medium. Blister may also be caused by hydrogen environment. E. Failure at the tube connection and assembly plate. Tube failure are classified as in service failure in boiler. This failure can be grouped under 6 major causes. One is stress rupture, 2 fatigue, 3 water side corrosion, 4 erosion, 5 fire side corrosion, called also as high temperature corrosion, 6 lack of quality control. A fire tube door explosion. During the ignition or operation of oil fire boiler or gas fuel boiler, the furnace and draining smoke tube will explode because of improper operation, such as incompletely cleaning the furnace before ignition, leak in the nozzle, or insufficient combustion, not promptly cut off the burning flame. Beside the secondary burning is damage to the furnace wall, chimney and other component of boiler. The explosion-proof door are used for usually gas emission to relieve pressure and prevent explosion accident, which is one of the safety accessories for oil and gas fire boiler. Requirement when use explosion-proof door. One is oil or gas fire steam boiler must be installed. Explosion-proof door. Explosion-proof door generally be arranged in the side of the furnace wall or top of low outlet tube. Second, installation and use explosion-proof door should not endanger the safety of person. Third is regular maintenance to prevent being rusted is needed. Four is inflammable and explosive material should not be placed near explosion-proof door. Five, the number and area of explosion-proof door should be set by calculating reasonably. And six is sealability of explosion-proof door should be guaranteed.
Assalamualaikum. My name is Nur Aidullah. So I will continue this presentation. The definition of basic boiler engineering is a steam boiler or steam generator is a closed vessel in which water is heated, vaporized and converted into steam at a pressure higher than atmospheric pressure. There is 7 functions of boiler, which is the first one is to operate steam engines and steam turbines, to operate reciprocating pumps, for industrial process work in chemical engineering, for producing hot water required to be supplied to room in very cold areas, used in thermal power station, and the last one is to heat the heat content of the steam is large and thus it is suitable for process heating in many industries like sugar mills, textile mills, dairy industry and also in chemical industries. Next is high pressure boiler and low pressure boiler. For high pressure boilers are built to a maximum allowable working pressure MAWP above 15 psig, but water tube boilers are typically built for high pressure needs. Low pressure boilers are designed for operation at 15 psig or below. Low pressure boilers are most commonly utilized in heating applications and require less maintenance than that of a high pressure unit. The differences high pressure boiler and low pressure boiler is in high pressure boilers, steam pressure is above 15 psi. While in low pressure boilers, steam pressure never goes beyond 15 psi. Hot water pressure always go beyond 260 psi for high pressure boiler and water pressure never go beyond 260 psi for low pressure boiler. The temperature in high pressure boiler will always be greater than 250 degree, while the temperature in low pressure boiler will never be greater than 250 degrees Celsius. For the safety due to high working pressures, these boilers are required to be checked all the time in high pressure boiler, while for low pressure boiler, since these boilers work on low working pressure, they don't need continuous check. For high pressure boiler, applications involve production of steam in power plant and in industries, while in low pressure boiler, these are used for water heating and steam, which is used to heat rooms. In high pressure boilers, for similar size, the output is relatively high, while in low pressure boilers, for similar size, the output is relatively less. It requires high maintenance for high pressure boiler, while for low pressure boiler, it requires low maintenance. And the last one is the operating costs are comparatively high for high pressure boilers and the operating costs are comparatively low for low pressure boilers. Next is boiler mounting and essential fittings. The boiler mountings are fittings which are mounted on the boiler for its proper functioning. Mountings are water level indicator, safety valve, pressure gauge and others. It may be noted that a boiler cannot function safely without the mountings. Following are the important boiler mountings. The first one is water level indicator, pressure gauge, safety valve, stop valve, blow off, feed check valve, and the last one is fusible plug. Water level indicator. It is an main fitting in the boiler. Water level indicator indicates the water level inside the boiler. It is a safety device upon which safe working of the boiler depends. Pressure gauge. Pressure gauge are used to measure the pressure of steam inside a steam boiler. The pressure gauge is fixed in front of a steam boiler. Safety valve. These are the devices attached in the steam boiler for preventing explosions due to excessive internal pressure of steam. Steam stop valve. The function of a stop valve is to control the flow of the steam from within the boiler and to stop it completely when required. A stop valve or junction valve is used to regulate the flow of steam from the boiler. Blow-off valve. The function of a blow-off valve is to remove periodically the sediments deposit at the bottom of the boiler while the boiler is in operation and to empty the boiler while it is being cleaned or inspected. And the last one is feed check valve. When the level of water in the boiler falls, it is brought back to the specified level by supplying the additional water called feed water. The pressure inside the boiler will be high, therefore the pressure of the feed water has to be raised by a pump before it is fed into the boiler. The feed water under high pressure is fed into the boiler through the feed check valve. Next is natural boiler water circulation. Referring to figure 1A, in the downcomer, pipe through which flow is directed downwards, no steam is present and the tube section AB is not heated. Heat input generates a steam water mixture in section BC, usually referred to as riser, pipe through which flow is directed upwards. Due to the fact that the steam water mixture at section BC is less dense since it is hotter compared to the water of section AB, thermosiphonic effect gravity will cause the water to flow downwards at segment AB and upwards at segment BC towards the steam drum. The effect of heating surface size on the boiler capacity and efficiency is hot flue gases from the furnace also contribute to increasing steam temperature in the superheater. Hot flue gases then pass through the boiler bank, resulting in additional water evaporation. After that, they pass successively through the economizer, in which feed water temperature is increased and the air heater, in which air temperature is increased, before being exhausted to the atmosphere. It is known qualitatively that the boiler efficiency is increased with the heating surface area of each component. Next is boiler horsepower. Boiler horsepower is a boiler's capacity to deliver steam to a steam engine and is not the same unit of power as the 550 FTLB/S definition. One boiler horsepower is equal to the thermal energy rate required to evaporate 34.5 pounds, which is 50.6 kg of fresh water at 212 degree, which is 100 degrees Celsius in 1 hour. In the early days of steam use, the boiler horsepower was roughly comparable to the horsepower of engines fed by the boiler. This is a step of installing a boiler. Step first is select the location. Step 2 is dressing the boiler. Step 3, supply and return pipes. Step 4, flue or smoke pipe installation. Step 5, gas pipes installation. And last is start to your boiler. Next, method of strengthening boiler drum construction. A control loop using height controller gain and derivative action may work well in other level applications, but it will quickly go unstable on a boiler drum level. Stability is best achieved by using a low controller gain, long integral time, and no derivative. However, these settings make the controller's response very sluggish and not suitable for controlling a process as critical as boiler drum level. Drum level is affected by changes in feed water and steam flow rate, but because of the very slow response of the feedback control loop, changes in feed flow or steam flow can cause very large deviation in boiler drum level. Single element drum level control can work well only if the residence time of the drum is very large to accommodate the large deviations, but this is seldom the case, especially in the power industry. For this reason, the control strategy is normally expanded to also include feed water and steam flow. Next, I will pass to Yuan to continue this presentation.
1.3 Fire tube boiler and water tube boiler. So for fire tube boiler is the type of boiler in which the water is flowing outside, surrounded the tube, and hot gases which are produced by the combustion chamber are inside the tube, and the further boiler is used to rotate the turbine blade and that used for the generation of electricity. So for the advantages and disadvantages of fire tube boiler is shown as above diagram. Fire tube boiler is in a simple design and is cheaper than the water tube boiler. The maintenance cost is kind of low and cost-effective heating solution. The procedure of cleaning is very simple for fire tube boiler, and to operate a fire boiler no need for skilled operators. A fire boiler can be used in small industry. For the disadvantages, the fluctuation of load cannot be easily handled, the rate of steam generation is slow, and fire tube boiler is used in a small power plant only. The maximum working pressure is up to 20 bar, which is a less comparatively water tube boiler, and the overall efficiency is up to 75% only. So there are 6 types of fire tube boiler, which is the current boiler, Cornish boiler, locomotive boiler, simple vertical boiler, and Scotch marine boiler. And 1.3.1 water tube boiler. The water tube boiler is a vital component of many industrial systems, while water tube boilers are available from a variety of suppliers and companies, as well as various manufacturers and distributors. So the advantages of water tube boiler is safe and easy for operation, fast reaction compared to steam demand, provides high efficient performance up to 90%, rapid heat transmission, require less floor area for a given output, can be easily transported, easy access to all parts for cleaning, inspecting and repairing, can tolerate high steam pressure, large evaporative capacity. For the disadvantages, which the water tube boiler need a high maintenance cost, complicated and time-consuming installation procedure, and water tube boiler cannot be manufactured in package form, and e-commercial for the small industry. There are 3 types of water tube boiler, which is Babcock and Wilcox boiler, Stirling boiler, and simple vertical boiler. So there are 2 types of drum, which is cross drum boiler and longitudinal drum boiler. So for the cross drum boiler, the drum is in this type is placed in cross to the heat sources. The temperature obtained in this type of arrangement is more uniform. When the steam loads are high, the upper tube can become dry, which causes them to fail. The layer of the tube is made in such a way that large number of tubes are made available. The capacity of cross drum range from 700 kh per h to 24,000 longitudinal drum boiler. The feed water is fed in drum. The drum is placed above the heat source. The cooler water goes to the inclined tubes and the water is heating eventually in the hot tubes. As the water boils, its density decreases and there is circulation of hot water and steam. Steam is separated from water in steam drum and taken out. Longitudinal drum boiler range from 2,250 kg per hour to 3,600 kg per hour.
Okay, everyone, and now we're gonna move to the next, which is 1.4, heat saving instrument in steam power plant. So the first component is steam purifier. So basically water is heated to boiling and converting steam, leaving impurities behind. So it is known that steam produced in steam generator usually contains normally solid impurities that are either in the vapor state or entrained by the vapor as small solid particles, or are carried by the water mist contained in the wet steam in solution in the mist, being subsequently released when the mist is vaporized upon the superheating. And next component is a superheater. So superheater is actually a device that has been used to convert saturated steam or wet steam into superheated steam or dry steam. So superheated steam is used in steam turbine for electricity generation and steam engines, and in process such as steam reforming. There are three types of superheater. First is radiant, convection, and separately fire. And next we're gonna take a look at how it actually works, the working principle of superheater. So as we all know, steam produced from boiler without a superheater will either be dry saturated or more likely wet. So in work where steam is transmitted over long distance and the inevitable heat loss from pipe surface cause the steam to become even wetter. So at the point of use, unless the superheater is fed to the boiler plant, this is the spread battery of pipe placed near the boiler furnace through which steam passes to receive the additional heat by either convection or irradiation. So the superheater increases surface area capable of accepting heat, and the production of heat also slightly increases the thermal efficiency of the boiler. And now we're gonna see what is the use of superheater in industrial boilers. So the first, superheater are used where only dry steam is required in process machine such as turbine. So any moisture contained in steam in such case happen to degrade or corrode the machine, thereby affecting its average operating life. So superheater used to convert low quality steam to high quality for end user. Next, some superheater is also needed when we need to transport steam to far off place, as there are some temperature loss during its transportation. So the third, superheater can be used in steam engine where absolute dry steam is needed to prevent wear and tear of engine parts. And next slide is a method that used to control the superheater. So here are a few methods. The first is control of gas circulation by damper. So in this case, basically the mass flow rate of gas circulation is reduced to convective superheater having constant flow rate of steam. It will result into reduction of temperature of superheated steam. So this can be achieved by placing damper in the gas pad before the convective superheater to bypass some of the gases around the superheater. And next, the method number 2 is separately fired superheater. So instead of using the flue gas of a boiler for superheating of steam, we may use separately fired furnace for the same purpose. So this method actually leads to very high degree of control of temperature of superheated steam. In spite of its precise control on temperatures, this method is not employed in a modern steam power plant because it is only economical. So for this reason, this method is only used in industry. Next, for the last method is the superheating in a temperature. So what is a temperature? So a temperature is actually reduction in temperature of superheated steam. It also called as the superheating. So a temperature can be achieved either by injecting water spray before the superheater or by injecting water in between the section of a superheater. So the control of a temperature by injecting water through the nozzle into the stream before convecting superheater, or in the short term called CSH. So next, the water from boiler or economizer is sprayed by the nozzle at the throat of a venturi constructed into steam pipe. And after that, the sprayed water mixed with incoming high velocity, and then the water receives the heat energy from incoming steam and it vaporizes. So as a result, the temperature of the steam reduces, and then the vaporized water and steam both flow down and finally supplied to the CSH. And then the thermal sleeve made of high chrome steel is also provided. So below here, as you can see, is a schematic diagram to see more clearly on how actually this method work. So next is a feed water heater. So feed water heater is actually used in a conventional power plant. Basically is a component for steam power plant that has been used also to preheat boiler feed water. So the source of heat is steam bled from the turbine, and then the objective is to improve the thermodynamic efficiency of the cycle or reduce the irreversibility involved in steam generation and reduce plant operating costs, and also have to avoid thermal shock to the boiler metal when the feed water is introduced back into the steam cycle. So the most common configuration of feed water heater is a shell, and the tube is exchanged with the feed water flowing inside the tube and the steam condensing outside. So as you can see at the example of a schematic diagram, there's two feed pump and then generator. So this is the objective of feed water heater. So the objective is to supply enough water to the boiler to match the evaporation rate. So for the subtrical plant, because the separation of steam from water always happen at the drum, maintaining the drum level literally represent the balance between the feed water supply and the steam generation. Next component is economizer. So what is economizer? So economizer is actually used to raise the temperature of feed water with the help of waste heat, energy or gases before it is supplied to the boiler. So basically it is a heat exchanger mostly used in a thermal power plant. So the temperature of a gas is about 250 Celsius to 550 Celsius at the exit of the last heater or superheater. Large amount of heat energy would have been wasted. So it reduces the amount of heat to be added to the steam in the boiler per kilogram steam. So it means It means the rate of steam evaporation rise at the same time rate of supply by burning the fuel in the boiler, and it is similar to the convective type superheater. So in most cases, this economizer is placed between the convective superheater (CSH) and the air preheater, so in between. So the economizer is made of cast iron usually, so to avoid the water hammering due to the boiling water. So feed water temperature must keep at about like 40 Celsius below the saturation temperature of the steam. So to see more clear on how it works, so here is I also state the schematic diagram of the boiler with the economizer system. So below the chimney is the economizer. Next slide is air preheating. So an APH, short term for air preheater, is a generally term to describe any device or component designed to preheat the combustion air using a fuel burning furnace for the purpose of increasing the thermal efficiency of the furnace. So the purpose of air preheater is to recover the heat from the boiler flue gas by reducing the useful heat lost in the flue gas. So here is a schematic diagram, also the schematic diagram of generator of a steam generator in conventional coal-fired power plant that also use air preheater. Next is the soot blower. So what is the soot blower? So basically, as we all know, the fuel used in a thermal power plant causes soot. So, and this is deposited on the boiler tubes. So economizer tubes, air preheated tubes, and else. This is directly reduced amount of heat transfer of the heat exchange, and then the soot blower is a device for steam power plant to remove the soot that is deposited on the internal furnace tube of a boiler during combustion to prevent plugging of the gases passed and maintain boiler efficiency or control the formation of the soot and reduce its corrosive effects. So the type of a soot blower are fixed type, which may be the further classified into lane type and mesh type depending on type of spray and nozzle use. And then the work procedure of a soot blower. So basically, a soot blower works by directing a high pressure jet of steam, water, or air through nozzle onto the cleaning surface, thus preventing a deposit build-up which will adversely affect the heat transfer efficiency of the heat exchange. So the air, water, and steam are most commonly used cleaning mediums. Lastly is the steam traps. So steam trap actually is an automatic valve that holds the steam at a load until it gives up and heat energy condense the water, also called condensate. After the steam condenses the water and the steam trap allow only the condensate to pass, thereby contributing the plant efficiency. So what are the use of steam traps? So steam traps usually used to remove the condensate, and these are also used to ventilate the system during startup and during operation. So the steam trap must cope with varying capacity and pressure and closed for steam Armatech in 2004. So there are basically two different types of steam trap. The first is thermal and next is mechanical, and the function of a thermal steam trap is based on temperature difference between saturated and condensate that is somewhat cooled. So there are several variants of which capsule steam trap and bimetallic steam trap are two examples, while for the mechanical steam trap work from the basic, the that steam and condensate have different densities. That's it from me, and now I will pass to my group mates, Shukri.
Thank you to Susan. Next, I will explain about regulation and procedure need for steam power plant. Regulation for steam power plant. Operation and maintenance cost is high. Time needed for erection of plant is high before it is put to operation. Large quantity of water is needed. Number 2, required in the plant to ensure the correct operation of the entire process. Rapidly following the grid load demand and controlling relevant process variables such as throttle pressure, superheater or reheater, steam temperature, so that high efficiency, durability and safety can be attained in the plant. Number 3, controlling the drum water level within a given tolerance is important for the safe operation of the plant. Measurement needed to know how often a plant is running at maximum power. A plant with a capacity factor of 100% means it producing power all of the time. A low energy path to examine the reliability of various power plants. Safety procedure for steam power plant. For safety training is essential when working in a plant. Employees must be aware of all safety procedures, especially as they pertain to their specific position. Special training should occur periodically to reduce the risk of accident. Safety equipment. All workers should wear the required safety gear while on the premises. The equipment must also be kept clean and maintained. Wearing loose clothing or jewelry while on the job should be avoided. In addition, people with long hair must keep it tied back when working with moving machinery. Working with tools. All tools should be kept clean and in perfect working condition. Any defect should be immediately reported. Also, no tool should be left in a location not meant for storage. Never open or enter rotating equipment until it has come to a complete stop and its circuit breaker is locked open and any other drive devices are immobilized. Some type of rotating equipment can be set into motion with very little force. This type should be locked with a breaker or other suitable device to prevent rotation. Do not enter a confined space until it has cooled. Push off combustible and dangerous gases and properly ventilated with precaution take to keep the entrance open. Station a worker at the entrance and notify the responsible person. Never enter a vessel, especially a boiler drum, until all steam and water valves, including drain and blown down valves, have been closed and locked or tagged. It is possible for steam and hot water to back up through drain and blown down piping, especially when more than one boiler or vessel is connected to the same drain or blown down tank. The importance of steam power plant. The steam turbine converts the heat energy of steam into mechanical energy. The generator then converts the mechanical energy into electric power. Our highly efficient and our environment-friendly power plants will contribute to the stable supply of electrical power and reduction of our environmental impact. For the conclusion, steam power plants are located at the water and coal available places. Steam is utilized to run the turbines. In turn, give the power to generator, and generator produce the electricity. The electricity is utilized for running the industry, for lighting of office, school. Boiler is an important component of the power plant. It produces the steam. That's all from our group. Thank you.